Hi, welcome to the Data Day. So today we are going to discuss about partitions, right? So partitions is a very famous topic in any RDBMS and in modern query engine. So when I say modern query engine, it's like in Hadoop we have something called Hive, in AWS we have something Athena, and in Google Cloud we have something called BigQuery. So these are like different query engines from different cloud providers, right? And so if you take RDBMS, like we have Oracle, MySQL. So if you take traditional RDBMS or modern query engines, there is a common topic which is called partition. And if you go for any interviews, right? So definitely for a data engineer or a data analyst, definitely you will get a question in and out with respect to that partition. The probability of asking about partitions in the interview is high. Right. And when it comes to performance optimization, partition acts one of the most important topic when it comes to performance optimizations, right? So partition. So when I say modern query engines, right? So traditional RDBMS, the storage format is like row oriented. And if you take any modern query engine like Hive or BigQuery or Redshift, they are called columnar data store, right? So it's just how one important point to classify these two like traditional and modern. So we have so many difference between, but one very famous difference between these two is, so all these RDBMS are row oriented and all these modern query engines are column oriented. So if you want to see the complete definition of what is row oriented and column oriented, I made a detailed video. You can find the video link in the description box of this video. Yeah, fine. Partition. So before we get into technical aspect of this partition with respect to RDBMS or modern query engine, let's first discuss about what is partition in general English, right? So what is partition? You split something is called a partition, right? So I want to partition this particular room, or I want to partition this particular file or a cake or something, right? So it's generally you split something based on a criteria, right? So for example, if you buy a new laptop, right? So you have C drive. So imagine this is 500 GB hard disk laptop, right? So now you will be like storing all your installation files, movies or study materials or personal documents, everything into this C drive, right? Then when you search for a particular movie file, you know the file name, but you want to search it. So when you do, it just scans the whole 500 GB disk, right? So that's the reason what we do after buying a laptop with one allocation of C drive of 500 GB, we split this into multiple partitions, right? So you will create one partition like D, and then D drive, F drive, right? So you are allocating 100 GB for D drive and then 100 GB for F drive. So you'll be doing like this. So imagine, so in D drive, I'm going to store all my movie files, and in F drive, I'm going to store all my study materials. Now you have a movie file name and you want to search for it, right? So you'll just get into this D drive and then you will search for the movie file. So that means your search scan is happening only in this 100 GB, not in the 500 GB, right? So that is the use case of partition, right? And one another example, let me just erase this. So one another example is, like, imagine that you have a folder, right? So if you take myself, I create all these videos, right? And before editing, right, I'll just put into my folder DE, data engineering. I create a main folder, and within this I'll create a subfolders. Okay. So I'll create a subfolder, like for Python videos, I'll put it in Python folder. SQL, I'll put in a SQL folder. So etc. I'll create so many other folders. So it's like I'm creating a partition based on the video topic which I'm taking, right? So here you create the partition based on what? X, based on what? So here this X is nothing but my topic. So based on the topic, I'm creating a partition, right? So I'm giving you a country, right? So if I give a country to you and I want a partition based on what you will think as a very first thing in your mind, based on what you have to split the country. So based on the state, and again the state needs to be get partitioned based on district, and then based on village, based on city, right? So based on something, you based on age, based on name, or based on gender. So the based on what is what we decide to create the partitions, right? So here I created two folder based on topic, right? So I'm going to relate this with a real-time example, but I just wanted to tell you these examples before we get into it, right? Okay. So now we understood what actually the partition is and what is the importance of it in a real world example. Now we get into the real-time example. Okay. So let me just create one table. Okay. So I'll just create one table with 4 columns: serial number, name, age, and when created at. So when this particular row got created, okay, serial number 1, and then the name I'll give as A, age is 26. This record created in 2023. 2, B, 33 is age. This record is also created in 2023. And third record C, which is 27. This is created in 2024. And fourth record is D, which is age is 28, which is created in 2025. So I have 4 rows and then I have 4 columns, right? So now we created the table, right? A solution architect or a lead senior level data engineers design the table, design the schema, and also they will decide which partition, like what kind of partitions I have to use, or based on what I have to create the partition, the criteria, right? So there are a lot of things that which we need to concentrate before creating or designing a table. One important is partition in your real-time databases, right? So you have commands like show partition, describe table, describe formatted table. So based on the query engine you choose, the command will be different. So if you see now, I'm going to show you an example in MySQL. So in MySQL, we have command to display all the partitions, right? So when you just describe the table, you will see the partition information of the table in the real world, in the real time, the production system. Mostly like 99% of the table will come with partition for sure, right? Okay. Now the very next question that we get in the mind is, okay, so based on what I have to create a partition for this table, right? So that is going to be the next $1 million question, right? So here this question, like something like let's consider X. So based on X you have to create a partition, but X is what here? Which column is X? Whether it is serial number or name or age or created. You can even create partition with more than one columns also, but then for now let's decide one column first of all, right? So here if you take based on what I will create the partition. So here based on what kind of transformation that you are going to do on top of this table, what kind of queries you are going to write, what kind of ETL logic you are going to write, or what kind of joins or aggregations that you are going to do, based on what column, the condition, right? So imagine now the transformation query is select name from table, okay, where created at 2023. That so here the created at is the condition which we are using to write this query, right? So that means you have to use this created at. The partition should be created for this column created at. See, while creating the partition, the syntax, anyway, I'm going to show you the DDL, the practical one. So we have to decide the column and then the column should be passed to that partition. Okay. So here we decide to go with created at, or they are writing a join query. Okay. Now imagine there is a join query. Okay. So I'm writing a join query like select, okay, select name from table 1 as T1, join table 2 as T2 on what? So T1 dot created at equal to T2 dot created at, or T1 dot created at equal to 2023. Right? So now here, even in the join, the ETL, the transformation, what you are doing, you are using this created at column. On top of this created at only, you are trying to do this entire join, right? So there may be lot of other condition for you. You can do on top of non-partition columns also, but primarily the condition should have a partition column for sure. Now we have to work with the downstream. Downstream means to whom we are going to build this table. So the downstream will have a query and we have to ask them. So in your query, so we build a table for you and you have a query, and in your query, what is the transformation logic, the condition that you have? Based on that, we will create partitions for the table. Right? And you can create sub partitions also. Now you can create a partition and under partition you can create a partition. Now imagine that you create main partition as created at, and sub partitions you can go with age also. Right. So imagine we have a country and I'm creating a partition as states, and under states I'm creating partition as cities. And under cities I'm going to create villages, right? So if I can even have more than one column as a partition, like main partition and sub partitions, right? So now imagine like how this gets stored in the disk. Okay, that is what the next thing we are going to discuss. See, if you in the disk, right? So now imagine you create this column as a partition, right? So in your disk, how this table will be get stored, and either you take modern query engine or the traditional RDBMS. In the like these all again the system design part. It's again this concept comes under system design also, right? So it will create partitions as 2023, 2024, 2025. Okay. So 2025 record goes to this partition, 2024 comes to this partition, and this first two records goes to 2023. Now if you take first two record A and B, this A and B record will be get stored, 24 is C and 25 is D. Now imagine I am writing a query and I say 2023. Now my read query comes to this particular partition only, it won't scan these two partitions. So this is unnecessary read because I have given 2023 and it knows created it is actually a partition column, and based on created it only the partitions got created. So it directly comes here. But the thing is, it comes here, but then now I write one more condition and name equal to A. Okay, so I just want only A record, but it comes to this partition, it scans both the record. It scans both the record. The reason is I haven't created partition on name. Okay, I just created partition on year only. So within this partition, full scan will happen. But again, within the partition, full scans needs to be avoided. Then you can go for subpartition. So here in the partition, full scan will happen, but then it will ignore these two partitions. Okay, right. So now, if you take in partitions, we have two types: static partition and dynamic partition. So if you take RDBMS like MySQL, it supports static partition only. That means while creating a table, you have to mention create a partition for 2023, create a partition for 2024, create a partition for 2025. With existing whatever the data it is there in this particular column till day, you have to create a partition. Now imagine I created the table with all 2025, from 2023 to 2025, I created a partition and data got loaded. What if tomorrow or after 6 months, I am getting 2026 record means, then you have to manually alter the table, you have to add a partition 2026. Imagine 2026, 2027, 2 years you didn't add any partition. Then it will go to default partition. That means all 2026 record, 2027 record, it goes to one single partition. Till 2025, it creates a separate partition. And 2026, 2027, you haven't created any partition. So it goes to a default partition and all the record will be get stored in a single partition. So DBAs will take care of whenever a new partition comes into picture, a new date or whatever. See, even if it is a age based partition, whenever a new age comes, they will alter the table, they will add a partition. So here in MySQL, it supports only, like most of the traditional RDBMS will support static partition only. But dynamic partition means I will create a table in the partition, and practically when I go with the SQL command, I will create a table. While creating, I will say create partition on created at. That's all. I won't say create one for 2023, 2024, 2025 like that. I won't say it. Just I will say create a partition on created at column only. Now imagine if a new year comes into picture, automatically the table will create the partition and load the data to that particular partition. So if 2026 is coming, automatically it creates one partition 2026 and then the 2026 record goes here. So example, which kind of DB supports this dynamic partition means Hive. In Hadoop, we have a query engine called Hive. It's a columnar data store. And in BigQuery, like Google Cloud BigQuery, all like supports this dynamic partition. So I have made a video in Hive how the dynamic partition works. So the video link is there in the description box of this video. You can have a look. I recommend you to watch that also. After watching this complete video, please do watch my Hive dynamic partition video as well. So you will get an idea. Okay, so we discussed all about this, right? So finally, before we get into the practical, I want to tell you something. You will be hearing a word called partition pruning. Partition pruning. Okay, so this partition, and there is one more thing called predicate push down. Okay, predicate push down or partition pruning means, see, imagine now you write a query, select name from table, okay, where age equal to 26. Now when I run this query, what will happen? See, this table is partitioned table. Okay, if you take this table T1 is a partitioned table, but it is got partitioned with created it. But you written a query with the condition of age 26. Age is not partitioned for this table. Now full scan will happen. Okay. So now when you run this query and you say, Gautam, the query is very slow. Now what I will say, right? Check whether partition pruning is happening. So that time you will hear the word. Your lead or your colleague will say, when you say your query is slow, your colleague can tell you, check whether pruning is happening. Pruning means whether partition is working or not. Okay, you can get that in the plan, explain plan you can get. I'll show you in the demo, right? Or otherwise, they will call that as predicate push down, means whether the partition is working or not. Predicate push down is happening means, or partition pruning is happening means partition is working. So that means you have to alter this query. So before this age, you add one more condition created at 2023 and you put age equal to 26. Then partition pruning will work. Because sometimes people, without knowing what column the table has created with for the partition, they will start running the queries. Okay. So that time what we will ask is just check the table schema and see on which column the partition has happened. Based on that, you trigger the query is what we used to say. Right. So now let's get into the practical part. Okay, so now if you just see here, right, so the practical one, so I have two tables. One is order normal and then orders partitioned. Okay, so if you see here, I have order ID, user ID, amount created it, and here order ID, user ID, amount created it, and in primary key I'm just putting my order ID and created it, because the partition column, whichever you are going to make as a partition, and that column should be part of primary key. Okay, and then so if you take in MySQL, you have to create partitions like this only. So this is what I was saying, like it is a static partition. See, for 2023 2023 for Jan, Feb, March, April, May, June, July. So I'm just creating month wise partitions, right? If and I have one called PMax, which is like a default partition. So any date that comes beyond this 2023-08, imagine 2023 10th month data is coming in, it goes to max value, this partition. Or if it is 2023 December or November, it goes to max value. It's all goes to single partition. So this is where what DBS will do when there is a new partition data comes. They will alter the table and they will add a partition, right? So they have a automated script for that to monitor and then to do that. So it's all like DBS will take care of it. So this is the DDL to create a partition table. Okay, so if you take I told you to check my Hive dynamic partition video, right? So in that, the table DDL is very simple. So like I'll just put partition by created it. That's it. I won't do all these stuff. So that is dynamic partition. I don't want to mention any of the partitioned datas like this. Okay, fine. So now let's create these two table. Okay, so let me just create this order normal. Okay, and then I'll create this orders partitioned table. Okay, created. So now I have a Python code which will load 1 million records. I use Faker library to populate the data for this table. Okay, so this code is also there in my GitHub and I've shared the link in the description box of this video. You can have a look. So let me just run this. So this will just load to orders table only. Means this first table, it will just load to orders normal only. And from that table, we can load it to orders partition. Okay, so I'll just run this Python code. So this will just load 1 million records to my table. It won't take much time. Okay. So if you see here, it inserted 1 million rows. If you want to reduce this to 50,000 or 10,000, you can do it. Okay. Just you can change the code, the count here, and you can do it. Okay, fine. So let me just go here and then run a count star from orders underscore normal. Okay, so 1 million loaded, right? So now what I'll do, so here if you see, I have an insert query, insert into order partition, select star from order normal. That means from order normal, you are inserting it to order partition. So just copy this. Okay, just run it. So this is just copying the data from orders normal to orders partition. So by the time when it writes to this order partition, the partition also will be get created in underlying. Okay. So it is loading the data by creating the partition and then it will load. Okay, so it says like 1 million records got loaded. Fine. So now what I'm going to do is, see, if you see here, we have this explain format equal to JSON. So explain is a keyword generally we use to add in front of our select query just to see the plan, the query execution plan, like what is happening in the behind the scene, right? So now I'm just doing select. And I want this to be in a JSON format. So I'm just putting explain format equal to JSON. Select star from order partition where created at is 2023-0701. Okay, so 0701, it comes here, right? So what I'll do, I'll just copy this. Okay, so let me just clear the screen. System CLS will clear the screen in MySQL. Okay, let me run this. Okay, so if you see here, right? See, it says partition P 2023 underscore July. Yes, of course, it goes to this partition. So when you get this right, and that means the partition is happening and partition is there. Okay, so now next. So next, what I'm going to do, so I have something called profiling. Okay, so I'm just enabling this profiling. Okay, so this profiling will show you the duration, the time taken of each query. Okay, so now let me again clear the screen. Okay, now I'll just enable this profiling. Now coming back, what I will do, I'll just run this order normal. Okay, created it with this. The first I'll run this. This is no partition, nothing. Okay, it does a full scan. Okay, so I'll run this. So it says like we have this much count, and then next I'll go for this. Okay, okay, fine. So if you see here, right, so the count star, if you take for order normal, the time taken is 0.25 second, whereas with the partition, it took 0.02 seconds only. But I can still show you more. So now profiling enabled, and then you executed the query, right? Now you run the show profiles. Okay, now you run this show profile. So you can see like how long the duration of each of this query has taken after enabling the profile. Okay, so if you see order normal took 0.24 seconds, but then with the partition it took only 0.02. The drastic difference you can able to see, right? Yes. Now you can also run this. So explain analyze. So either you can go for profiling or you can go for explain analyze also. Let me run this as well. So explain analyze and the same query. Okay, so just I'll run this. So here you can see the table scan and all those stuff, this information you will be seeing here. And then also like I'll trigger the order underscore partitioned as well. So that also with explain analyze I'll do. So here also you will get all this duration and all those stuff. So the durations you can see here as well. So let me just clear the screen. Okay, so either you can go for profiling or you can go for explain analyze, or whichever the DB that you are testing this, you have to check what equivalent explain command or this profiling you have. You can use that to show them that the pruning is happening, the partition is working, like that. And also I have the command here. So if you want to alter partition, see alter table order partition, like you want to drop it, yes, you can drop, or you want to add a new partition to the existing table, you can add like this. Okay, or you want to drop and then add at the same time, you can do this. So these all DDLs and the commands, I'm going to add it in my GitHub page, and I'm sharing that link also. You can find the link in the description box of this video. See, this is something like when you are in a beginner level of your experience and you explain all these with these use cases, whatever I have explained in this video, right? So this will create some impression in your interview with your interviewer, right? So, and also this is very important for a data engineer or a data analyst or any data related professions you go. This kind of partitions are much important to be aware of, and especially partition pruning and predicate push down. When a newcomer comes to the team or even experienced person who migrate his tech stack to data, for them these terminologies are very new, and there you few say that yes, you know these terminologies, right? Then they will consider you so special, right? So thanks for watching, and I hardly recommend you to watch my Hive dynamic partition video as well. Just forget about what is Hive and all, just get into that video and just see like how the dynamic partition is working. Okay, so thanks for watching, and to get all data engineering related videos, you can just subscribe my channel and have the videos. It's there in my YouTube channel. I have around 20 hours of big data master course video in my channel, so that also link I have given in the description box of this video. You can have a look. Thanks for watching, guys, and please do follow my Instagram page as well.